So I can't believe how fast this year is flying by. We are on Congruence and Proportions in Similar Triangles, and this is 8.4 in your books. This is going to be a fairly short screencast. The next one will probably be shorter as well as we get here to the end of the unit. The concepts in this are important, though. They're big concepts, short lessons. All right, so the objective. Use the concept of similarity to establish the congruence of angles and the proportionality of segments. What does this mean? Well, basically we're either going to first show that triangles are similar and then use that fact to show something about angles or proportionality of segments, or we're going to be given that triangles are similar and we're going to have to show that. More often than not, though, it's going to be the latter rather than the former. All right, so it's like CPCTC, but it's different. Okay, with CPCTC, you would show that triangles were first congruent, and then we would use that to show that certain parts of triangles that we didn't know before were also congruent. So with similarity, once we know that two triangles are similar, we can show that the corresponding sides of the triangles are proportional, okay, not congruent, but proportional, and we can also show that the corresponding angles of the triangle are congruent. So remember, sides, proportional, angles, congruent. I wish I could think of a clever way for you to remember that, but I really can't right off the top of my head. Maybe by Monday I'll have something. But anyway, let's move on. You had this question on the quiz, and we've kind of formally stated it. You knew this already. But if you took the quiz and you got to that last proof and you weren't sure what to do, this should help clear that up. Now, that dot does mean multiplication. So we're given that segment RP is parallel to segment TW. And we're given that RS is congruent to SP. So we have our givens. Now, I can't stress enough that when you have a proof, if you're stuck on it, you should not only have the first step. I mean, that's a given. You should have that. But if you're stuck, figure out what that helps you prove. Okay, we've got two lines that are parallel. We know a bunch of stuff about parallel lines. Okay, you've got this line is parallel to this line. Well, everything we know has to do with angles and transversals. So we actually have this segment here that runs through it. That's a transversal, and so is this segment here. Okay, so we're going to be able to use that to help us out. If you get stumped on that, maybe the second thing helps you. So we have that RS is congruent to SP. So we know that these two are equal in length. S is a midpoint. We don't necessarily have to state that S is a midpoint, but it may come in useful. So let's start with the parallel lines. That tells us that, well, actually, you don't even have to go there right away. You could say, well, I kind of noticed this here, and there's got to be a reason for drawing these lines in here. So this one doesn't tell me a whole lot because this is a triangle, this is a quadrilateral, but I've got two triangles here. So why don't I say that RJS is congruent to WJT because vertical angles are congruent. You can then move on to say that, and here's where these parallel lines come in, that angle JRS right here is parallel to angle JWT, and that's because alternate interior angles are congruent. Well, look what I got now. I got two triangles, and I've got angles from each of them, so I can say that RJS is similar to WJT by angle, because I have an angle from each one of those. So that would help you. The other thing that you could have done is you could have said, instead of, if you didn't go with the vertical angle route, even if you didn't see that, you could have said RJ or RSJ and WTJ are congruent also because of alternate interior angles. So there's two routes you could have gone there, and it would have shown you the triangle similar by angle, angle. Okay, so now I've got these two triangles similar. So I've used this already. Okay, I haven't used this though, and I have to show that SP times TJ is the same as TW times SJ. Well, if you look, okay, take a step back. I've got TJ, I've got TW, and I've got SJ. All three of those parts belong to either one of the two triangles that we already proved similar. SP doesn't. However, I know that RS is proportional to TW because the triangles are similar. I also know that RS and SP are congruent. So first you have to state the proportionality. RS is proportional to SJ, and that proportionality is TW is proportional to TJ. Okay, it's the same proportion. Even if the triangles are different sizes, the proportion of this to this and this to this is equal. The proportions are equal, and that's because corresponding size of similar triangles are proportional. And then we can use this right here and substitution and say, well, not RS, let's use SP this time. SP is proportional to SJ, and that proportionality is equal to TW over TJ. Okay, now we've got our proportional, and we can go back, and I told you this is from 8.1. Okay, we've got the means extreme product theorem. So now we take basically SP times TJ, and that's equal to SJ times TW, or whichever way you want to put it. But we use the means extreme product theorem there. So you might want to go back and look at, because there's two theorems there that are going to be useful moving forward. That's one of them, and you can go find the other one for yourself. All right, and I would highly stress that you study this particular proof. That's all I'm going to say. Make sure you know this proof. All right, let's look at a second example. Maybe this one's a little bit easier. Okay, we know that ACB is a right angle. And we know that CD is an altitude. So now we need to prove that CD squared equals AD times DB. So, start with your givens. ACB is a right angle, and CD is an altitude. That's your given. Okay, ACB is a right angle. Fantastic. Wonderful. So, well, we can also say that from the CD is an altitude, that BDC and ADC are right angles because altitudes form right angles. All right. And what do we know about triangles? There's 180 degrees in a triangle, and if one of the angles is 90 degrees, that means that the other two angles have to add up to what? Okay. Keep that in the back of your mind. Moving on. We know that since this is a right angle, we know that BCD is complementary to ACD because complementary angles form right angles. Okay, we also know that angle A is complementary to angle ACD. Now notice, okay, BCD and ACD, those were easy to see because they were right next to each other. But remember, in triangle ADC, we have a right angle, which means that the other two angles have to add up to 90. And if they have to add up to 90, then that means that they're complementary. Okay, so we've got angle A is complementary to angle ACD. So we can say angle A is congruent to angle BCD because angles that are complementary to the same angle are congruent. So now we know that this is congruent to that. Okay, you see where we're going with this? I know this is going to be a little confusing, but once it starts to click, you'll get it. You've gotten really good at proving triangles, so this is just kind of one more step. We're moving from congruence to similarity. We also know that ADC is congruent to BDC because right angles are congruent. And we can say triangle ADC is similar to triangle CDB by angle, angle. And see, we're going to go back to this. Proportions. we've got AD over CD is equal to CD over DB. Okay, notice the sides that correspond and everything. And then finally, CD squared equals AD times DB, and that's the means extremes products theorem. Okay, so again, we need to keep this in mind, because if you notice, CD times CD is CD squared. Okay, and AD times DB, basically we're just saying, okay, so if I take, it's like cross multiplying. If I take what's diagonally from each other and put them together, we can say that they're equal. So that's basically what this unit boils down to. When you work on the problems in class, I want you to ask questions and get help and get it cleared up. Don't just do it and wait for the answers and have that be that. I want you to understand it, so please ask questions. All right, we may have a guest speaker for the video tomorrow. Just a heads up, 6 hour, you already knew that. All right, have a good one. Hope you take good notes. Do not forget about the quiz that goes along with this, and do not forget to bring your notes into class. I need to see those notes. Okay? Thank you. Have a good one.